Hello, our project topic is Global Data Analysis for Social Unrest Prediction. We want to predict social unrest events like violent demonstrations, protests, or riots across the globe based on different factors like poverty rates, hunger or crime rates, natural calamities, and also the historical event patterns. Application domain of this problem statement includes world governments, policy making, social science, and world hunger or disaster management. There are basically three approaches in our project to predict social unrest. The first approach, we are using data sets which has burst patterns of sequence of historical events so that we can use this stream of sequences to uncover the underlying event development mechanics and possibly predict the social unrest. In the second approach, we are studying factors like poverty and hunger rates to figure out whether these factors are leading to political or social unrest, and this might be a cause for social unrest in the near future. In the third approach, we decided to use predictors from Twitter feed. Since Twitter data is annotated based on crowdsourcing, we found out it's not reliable to predict the sequence of events. Also, using Twitter live streams is computationally challenging. Because of all this and other issues, we decided to exclude Twitter live stream for this iteration of the application. We faced three major challenges. There is limited work done in this area, and we had very little reference material. Hence, we ended up spending most of our time on extensive literature review. Handling historical data sets is very difficult because of their huge size, and it also requires expertise. We found that there are terabytes of data available for historical event sequences, and we have to have familiarity with Google BigQuery to extract all this data. Many data sets are available, but the problem is we have data sets available only for a certain period of time, and it makes it difficult to aggregate data sets without losing any key information for a specific timeline. So we have made use of the following data sets. The first and the main data set that we have used is global data sets on events, which is known as the GDELT project dataset. The initial EDA, we have performed comprehensive analysis using descriptive statistics to find out whether these findings would be helpful to predict social unrest. We had to integrate a variety of data sources based on relevance for a specific time period, and we chose to go with all the data available after the year 2000. Feature selection and engineering from available data sets was very important for us, and we figured out that it's very difficult to get Twitter feed as we do not have relevant data for Twitter from the year 2000. Analysis of Twitter feed is something interesting, and we hope to do it in the future iteration of this project. Currently, we're working on building competing models in order to predict how and when these global factors may lead to social unrest. We want to fine tune these models and find the best one with the highest accuracy. Our final aim will be to build an interactive UI using Dash to get a dashboard to access real-time social unrest prediction and other insights. In order to evaluate our models, we will be making use of a report known as the Golden Standard Report, which is compiled by independent groups of social scientists and subject matter experts. This would help us to calculate the risk factor, which would possibly help us identifying which factors might lead to social unrest in future. This is our data science pipeline. We have completed the data collection process and the analysis of the data that we have collected. We are also done with our feature engineering, and we are currently working on building models. Once we build the model, we have to iteratively analyze the model and restructure our EDA in order to make better predictions. The final deployment would be that of a dashboard using Dash. Our development methodology has been the Scrum methodology. We held bi-weekly meetings in order to resolve and discuss issues, and also which helped us to make decisions. Our documented meeting minutes were also very helpful to keep track of all the updates. For performing EDA and visualization, we have used Python with relevant packages in Jupyter Notebook. So this is our tentative timeline. We are done with our literature review and EDA. We have also experimented a little bit with Twitter API, but we are not currently using that. Our modeling process and the second iteration of EDA is still in progress. So by week 11 to 13, we are targeting at improving the model that we are currently building. We are also building our integrated front-end UI, and it's in progress. These are some of the key insights that we have got from our EDA. The insights shown here in the figure basically consists of the EDA of GDEL dataset. For the sake of presentation, we have taken Canada, China, USA, and Africa, and we have found out that we have observed maximum number of events in USA and China compared to Canada and Africa. The distribution of events across the year can be seen on the right scatter plot, and the frequency of events can be seen in the left histogram. But we do not know if these events were just regular events like social gatherings or if there were some sort of protests or riots. So we have narrowed down 5 types of events based on their intensity from the dataset. If there is a higher frequency of high intensity events, they can be classified as something like social protests or riots. And all this is represented in the red and the brown color in these mosaic graphs. And if the events are of low intensity, they can be classified as something like social gatherings or meetings, and these are shown in the green color as low intensity events in the mosaic graph. So if we compare the graphs of Canada and USA, we have observed that there's more social intensity in USA compared to Canada. So we're currently building on our second phase of EDA and modeling, but this is our first milestone presentation. Thank you for watching.